So I want to continue with our introduction to TypeScript. And by the way, most of you now, all of you indeed, will have received emails from AWS Academy. In fact, you probably received 2 emails. The second one is the more important of the 2. You can just go ahead and register as it's requesting you to. I know from talking to Richard Frisby that you have used this AWS Learner Academy last year, so you're familiar with the environment. I'm not actually, so I'm just getting up to speed on it. I think it'll be okay for us. There are 1 or 2 aspects of the environment that are a little bit awkward for what I want to do, but we'll see as we progress through the module as to how much we can use it. It would be a good idea to have your own AWS account anyway. And if we have to revert back to that, then we can do that. I don't see us incurring any costs of any note at all, really, as long as we are kind of disciplined and make sure that we tear down whatever resources we set up in the cloud. And it's just simply 1 command to do that anyway. But that's for next week at the earliest. So I guess I can just get going unless there are any questions you have for me. Right, so we know a fair bit about TypeScript at this stage. It's all about, from a syntax point of view, we began with this notion of annotations. That's how we declare a variable's type using this postfix syntax. That's fine. We can also apply it to function parameters and a function's return value. We have classes, even though I didn't talk about classes, but the example there on the right should be pretty understandable to everybody that has done any object-oriented class-based programming, which you all have. So I don't really need to explain that. Interfaces are available to us as well, which would be very familiar to you from Java, at least, maybe other sources as well. Interface data types are new. That was a way of defining a precise structure for an object. Type aliases kind of overlapped with data interfaces with the previous slide, but there are aspects of type aliases which we will look at today. Even though that I mentioned on this slide here, there are aspects of type aliases which the data interfaces don't cover. In fact, there are quite a lot of aspects of type aliases, and many of which we won't get around to looking at because we don't really need to know about them. Type inferencing was a really big winner with TypeScript. And the idea there was that the compiler can determine the type of a variable based on how you initialize it, and also from other sources as well. And I did say to you that initially you might find yourself unnecessarily being explicit about a variable's type when you don't really need to, but it's okay to be explicit. But as you get more experience, you'll find yourself literally typing less syntax because the compiler will work things out for you. But that only builds up over time, really. And we don't really have an awful lot of time. 12 weeks is not considered a long time to be working on a new language. Functions, that's fine. We can declare, we need to declare a function's parameters and its return type. Type inferencing can often infer the return type, though. Higher order functions, the idea there was that we need to, because now a function could be a parameter of a function. In other words, a callback can be a parameter of a function. Then we need to have a syntax for declaring a type for that callback. And so this is the kind of syntax that we use. We need to say what's the parameter type and what's the return type. That's how we declare a type associated with a function. Essentially, it's its signature. Optionals was this idea that if you have a data interface type, some of the properties within it may not be mandatory, and we indicate that with the question mark symbol. That's where we left it the last day. This is where we're going to pick up the story. When I get stony silence against me, it's great, but sometimes it makes you wonder, are there people there? Can people hear me? Can I just confirm? Anybody want to just confirm that they can hear me and see my screen?
Yeah, no, we can hear you.
Okay, yeah, it's just yeah, you're never certain from my side. Great. Union types. We've actually seen unit types already. So there's kind of a formal statement of what union types are. I'm saying union types, we use them when a variable can have a value of different types, and that can arise. So examples are always easier to work off of. So if you take this one here, I'm saying that size, sorry, bad drawing, size is a type, but its value could be a string or a number. And so here are two examples of it. These are two valid initializations of size variables. And, you know, this, I said to you before, this, you can interpret this as the kind of OR operator when we were talking about types. And it doesn't have to be primitives. It could be, these could be two data interface types that we've defined earlier on, or this could be a data interface, and this could be a type alias. And we're saying that role now, if we declare a role variable, an instance of a role variable, it may be assigned a student object or a lecturer object, or indeed a manager object. Literal types, on the other hand, a literal type is where you're saying a variable can only have a very specific set of values, if you like. You're limiting the range of values that a variable can have. So, for example, here, I'm declaring department as a type. This is a type now, right? I'm declaring it as a type, and I'm saying the only possible values it can have are these strings here. So whenever I declare an instance of a variable of type department, I can only ever assign it one of these strings. It won't allow anything else, and the compiler will complain. And we've got some examples of all of this going on in the archive that that's supporting all of this stuff. So if you go into the optionals, unions, and literals section, into the index.js, and I think if we scroll down.
Okay. Already did all this. Already did all of this. Why do I have to be in?
Sorry, somebody's got their microphone turned on. We can all hear you. Can you just mute your microphone, please? Okay, here I've got a simple standard type alias. Okay, that's it. Social handlers. I've got another standard type alias here. Mind you, I could have used data interfaces for either one of these. And here comes the example of a union type. So I'm saying contact could be social handle or address. And then I've got a user here. And one of the properties is this property here. So it's type. So I can assign either an address object to this property, or I could assign a social handle object to that property. So for example, this user here, I'm assigning, looks like I'm assigning a social handle, whereas this one here, I'm assigning an address. Now, there's one neat little feature that I just want to show you, but I guess maybe what I'm trying to get from this example is that the is get confirmation from somebody.
Yeah, no, we can see it again.
Right. So I've got a function here, right? And I'm passing it what am I doing? I've got an arrow function. I'm passing it a user. And the purpose of the function is to extract the user's contact details and just output them as a string. Okay, fairly simple kind of stuff, right? So it's returning a string. That's fine. And I've got a statement here. You see, the thing now is that, okay, I'm passing in a user. Their contact details is stored in the contact property. But we now know that this property could either be an address or a social handles. Yeah. And let's say the format of the string that we output will differ depending on whether it's an address or it's a set of social handles. So we need to determine in our function which type of contact is it. And as you might expect, we use an if statement. So, but the if statement, what I'm doing in the if statement here is I'm just picking out any property, let's say, of address that social handles does not have. So social handles, that type didn't have a street property. So if the contact for the user contains a street property, then we know that this here is actually an address object. Okay, now, so I'm assigning user.contact to a local variable here called contact. But if I ask the compiler, what type is this variable? You might think, well, it's going to tell me that it's a variable based on the definition of the user structure. It's a variable of type contact. But it's actually, it can be more specific. It can actually tell me that it's a variable of type address. And to prove it to you, if I go Command K, Command I, right, it's actually worked out. And it's worked that out in the same kind of way that we might work it out when we look at the code. Because when we read this code, we say, okay, that if statement is checking to see really is this contact property. If it contains street, then it must be an address construct. And the compiler is actually doing the same thing behind the scenes. What we say in TypeScript is that what we're doing here essentially with this if statement is we are narrowing down the type of the variable. In our case, we're narrowing our contact property from being a contact type to an address type, which means, and so we are returning inside in the body of that if statement. So that really means that this piece of code here, that's only going to execute if contact property of user is the other type, in other words, a social handle. And if I do Command K, Command I over this one, it works out that it is of type social handle. That's a fairly low-level specifics side of TypeScript, but I just thought I'd bring it to your attention. We won't necessarily be writing TypeScript code that needs to be that precise, but that's just by the way. Anyway, the overarching purpose of this example is to demonstrate union types, which brings us right back to here. The other type is the literal types, and here's an example of literal types. So I'm declaring a type called department, and it can only be one of these strings. And then I've got this fictitious function here, which if I pass it an instance of department, and I also pass it an array of users. Let's go back up to users. How do I know that now? Sorry. pass it an array of users. Let's see. Oh yeah, sorry. Okay, that's all right. Yeah. Okay, I pass it a department variable, and I pass it an array of users. And I'm doing some sort of check here. If department equals accounts, then do this. Otherwise, do this. It's not really important what the function is doing. What you won't get from this code is, though, if as I'm typing this code, so if I just get rid of this, right, as I'm actually typing this code, and I bring up, let's say, that, see here how it's hinting to me these are the only valid values that you could possibly be comparing this department variable to, because department is of type department, and I've set up here that these are the only possible values of department that department can have. So this is another example of the kind of IntelliSense that TypeScript gives us when we're actually writing our code. Whereas if we were doing this in JavaScript, we wouldn't get any assistance like this at all. Okay, that's literal types. They're very like enums, if you're familiar with enums, which I'm sure you are from other languages, Java in particular. The next aspect of TypeScript is generics. Generics is by no means unique to TypeScript. Many languages have it. And I think the first language to introduce this notion of generics was Java, and we're talking about maybe 15 plus years ago. So it's by no means a novel aspect of TypeScript. You may or may not have ever used generics. What's the idea behind it? Well, it's all about making your are allowing you to write code that is reusable. We love reusability when we're developing code. But the idea behind generics is it allows you to write a reusable piece of code, as in maybe a function or a class, where the data type being processed by that piece of code, the actual type can vary. Okay, so we have this notion of a type variable associated with a piece of code. So when we declare the piece of code, we don't have to be specific about the data type that the piece of code is going to be working on. Let's say it's just a function. It's only when we invoke that function that we can specify the type of data that it's going to be processing. That's the idea behind it. Again, I know I've said this a couple of times now. What you will find in this module is that you will see examples of generics in code that I show you and in code that you write, but it's highly unlikely that you will actually have to write generic code yourselves. All right, so it's important to be able to understand the idea, to be able to read code that utilizes generics, but you won't necessarily be writing your own code which avails of generics. So generics allows creating type variables which can be used to create classes, functions, and in fact, this generics idea is much broader than classes or functions. I'll show you one or two examples of other places that we can use it. We can actually use it in data interfaces as well, and type aliases, so it can be used all over the place. Here's from a syntax point of view, let's supposing we've got this function. Again, it doesn't really matter what the function does, but the functionality carried out by this function, this process function, let's supposing that functionality can be applied to a number of different types within my application. Therefore, I can reuse this function for different data types. Now, and down here, then I'm actually invoking the function. And the question is, how do I, when I'm invoking the function, how do I tell it which particular data type I'm passing it? And in the declaration, this is where you specify the fact that this function here is a generics function. Okay, so the angle brackets, or the angle brackets indicate that generics are being used. So this is telling us this is a generics-based function. T is my type variable. It can be called anything. It's just a variable. But in this case, it's a variable that's going to be assigned a type. It's not a variable that's going to be assigned a value. And other than that, my process function looks like it takes 2 arguments. But notice one of the arguments, its type is the same as my type variable, T. Again, I can use any, I can give my type variable any name. T tends to be a common name that's used, but it could be foo, whatever you want to. X, U, give it any name you want to, and it doesn't have to be a single character either. And wherever within the body of the function, wherever you want to either create an instance of a variable or process a variable of that type T, then you will use this T annotation on it. For example, here I'm using it on one of the parameters. I'm saying the first parameter is of type T. We don't care about the body of the function for now. That's only going to confuse us, possibly. Here's an example of me invoking my process function. And let's supposing I've defined somewhere else a data interface called person. So I'm saying now the first parameter, person X, that parameter is of type person. That's how the compiler kind of interprets this. And within the body of the function, anywhere I refer to person X, it's going to be a variable of type person for this particular execution of my process function. Here I'm invoking the process function again, but this time my type variable is box. So that might be, again, another data interface that I've defined somewhere else. That means the first parameter is going to be of type box, given that I've said here the first parameter, its type has to correspond to the type variable specified in my generics part of my syntax. Right, that's the idea behind generics, and this is the syntax associated with generics, the syntax here. And the fact that what you're declaring here are type variables as opposed to, let's say, data variables, variables that can hold values. Here, my variable is going to be assigned a type, as in here and here. Let's look at concrete examples. So just by way of background, you probably know, right? So I've just got an array of strings here. And of course, if I did Command K, Command I, the compiler would work out that this is an array of strings. There's no generics being used here now at the moment. And I'm invoking the sort method on my array of strings. And we know what sort does. And we probably know how to invoke sort. You invoke sort by passing it a function that controls how the sort is actually going to arrange the entries in my array. Okay, so that's just by way of background. This sort function, this sort method, you pass it a function. That function, by the way, has to return a numeric value. That's prescribed by sort. It has to return a numeric value. And if the numeric value is negative, then it knows that A is less than B. If it's positive, it knows that B is less than A. And if it's 0, then it knows that A and B are the same. And it simply uses this function to work out how it should reorganize this array. By the way, even though it's not important, the sort method, it actually modifies your source array. Whereas, filter and map and reduce, they don't modify the source array, but sort does. Again, that's not significant. I'm just telling you that by way of background. Now, my heading here, though, is here I'm not using generics. So let's supposing I want a function called string ranker. And the idea is I pass it an array of strings, and I pass it a function. And this function, the callback function, that's what's going to be used by my function to determine how it should order or rank the strings in my array of strings. Yeah, and it returns an array of strings. And all I'm doing here is I'm calling sort on my array of strings, and I'm passing it I'm passing sort the actual ranker function that is being passed into it. So am I invoking it? Let's see here. Okay, I'm invoking my function. I am not using generics here now so far. So the function, the function that I'm passing into it, that is going to be the basis of my sorting, looks like it's just going to sort the strings based on the length of the string. I could have another invocation of this guy. I could have an invocation where I pass it a function, and let's say the function counts the number of vowels in the string, and it uses that as the basis for sorting. Right, and here's an example of invoking it. I don't need to run the script now, but I'm hoping that you get the general idea of what I'm trying to do here. But I am not using generic so far. Moving on, I've got another function, and it's essentially doing the same thing, but this function is working on person objects. I'm passing it an array of person objects, and I'm passing it in a ranker function again. And in the case of person objects, it looks like, oh, sorry, okay. This is the signature of my ranker function. It takes a person object and returns a number. That's fine. Like if you look at this here, right, those two lines of code are the exact same as those two lines of code. So it would be great if we could actually combine those two functions into one, i.e. make it reusable. Hence, that's where generics come in. But we haven't looked at generics so far. Here, okay, I have that guy. Here I'm just declaring some person objects, and I'm calling my person by age function. Is that what I'm doing here? Yeah, I'm calling my person by age function. I'm passing it in my array of persons. And here's the basis for ranking my person objects. I'm just taking their age as the basis. We defined person objects, I think last week. So person, just before I do that, I think I'm importing. See here, I'm importing person there. And if we look at the definition of person, a person does have an age, but it's actually optional. So some people won't have an age. That kind of complicates it, but let's go back. Let's try and actually apply generics to our two functions. Which brings us to here. So sorter now is my generics version of all of this. And in this case, my generics function takes one type variable. By the way, it can be more than one. You could have 2 or 3 or 4 type variables, but it's only one in my case. I'm saying the first argument is an argument of type array of t. The ranker function takes a t and returns a number. The body is the same as before, really, but anywhere we had person or string before, now we have t. Now, because of type inferencing, I don't actually have to be explicitly referring to t anywhere in the body, but that's only coincidence. Like I could say that A is of type t. Well, if before I do that, if I do Is it smart enough to work it out, I wonder? If I just take this here, right, it's going to know that results is an array of type T. If I do Command K, Command I. Yeah, let's work that out. And okay, that's my generic version of my function. And then when I invoke the function, so here I'm invoking it with person as the type for T. I'm passing it in my array, and hopefully this better be an array of objects of type person, because that's what I said up here. It has to be an array of type T, and T is person in my case, in this case. So, and we know it is because we know we just declared those three objects up above, and they were all person objects. Here's my ranker function. Now, why am I doing this, I wonder? Like, why did I not just say that because I'm using age as the basis for ranking, and given that I've said the type for T in this case is person, so can I not just go p.age, just as I did, where was it? Just as I did, where is it? Just as I did, oh no, I didn't do it there either, actually. There was a reason for that. Okay, let's just stick with, yeah, maybe I could have explained it back here, really. Why did I not just go, p.age, that's the basis. Why am I doing this ternary operator? Well, the answer is, you see, some person objects won't have an age. So what are you going to do in that case? You can't, the sort won't work in that case. That's why I'm saying if p.age is defined, then p.age is the basis for sorting. Otherwise, I've just arbitrarily decided set the age to 30 or return 30 as the person's age if their age is not explicitly initialized. Now, supposing I took that out, and supposing I forgot about the fact that age is an optional field rather than a mandatory one. You can see down here I'm getting some errors. And essentially it's telling me, look, type number or undefined. You see, p.age now, p.age could be a number for an actual person, or it could be undefined if that person doesn't have an age. And it's saying type number or undefined is not assignable to type number. We know based on here, I'm saying my ranker function has to return a number. But when I'm using p.age on its own, then it's possible that that's going to be undefined, and the compiler doesn't like that. And this is one of the it's one of the great things about the compiler. It can be quite frustrating initially when you're learning the language. So it's just not allowing you to progress because it realizes you could potentially, your application could potentially crash because you're going to be feeding a person object that doesn't have their age property. And so the solution, in this case anyway, is to do that. And it's equally below. It's the same, we're still left with the same problem, but it's further down in our generics version of it. Yeah. So I need to put that back in as well. That issue there now that I've just been talking about, that arose when we weren't using generics at all. Right. So it's not necessarily related to generics. It's just this checking that's going on behind the scenes by the compiler. And I know I'm going to repeat myself now, but the compiler saw when we had the example that wasn't using generics, it saw that you said this that you said the signature of the ranker is this, right? Takes a person object and it must return a number. But then the compiler went looking at your structure for person. When you actually went to invoke the function, which we did here, and we were using p.age, it went behind the scenes and saw that age was not a mandatory property of person. Okay, it's a numeric property, but it wasn't mandatory. And for that reason, it says, it could possibly have the value undefined. Back to generics. So maybe we're juggling too many balls there now at once, but so if I pick up the story from here, yeah, so we're just, we're invoking our generics function with an actual type. And similarly here, we're invoking the same function. So I'm invoking it here, but I'm not telling it the type at all. This is my generics function now. So what's happening there is type inferencing is kicking in. Because, I know I'm scrolling up and down now, but if I go back up to where they defined my generics function, T is appearing here, and I'm saying the first element is an array of T. Okay, so the compiler knows that. That means that when I where are those? Yeah, when I call it here, the compiler works out, well, it looks at this array and it says that's an array of strings. So my type variable must be a string. It has inferred that. I can be explicit about it, but I don't have to be. Yeah, it doesn't change anything. Again, you wouldn't necessarily realize that, I don't think, as a beginner. And I'm passing it my sorting and string.length. Well, that's always going to be a value, so there's no problem with possible undefines. So that's generics. That's generics applied to a function. You can also apply it to classes. Further on down here, I'm showing you that you can actually apply it to interfaces. So I've got a microphones data interface. I've got a speaker data interface. And here I've got a box data interface, but it's actually generics based box. So it could be a box of any types of objects is what I'm thinking behind the scenes. So, and a box has two properties. It has a shelf number and it has an element that could be an array of T's. And so here I've got an example where I'm actually using my generics data interface. I'm declaring a box of speakers. So this has to be an array of speakers. And if you look at the structure of these guys and the structure of speaker up here, that's consistent. That works okay. So that's an example of generics being used for reusing some of your data structures. In this case, we're reusing the box data structure. And you can apply them, saying down here, you can apply it to type aliases, classes, etc., etc. I don't think you see any example of us using generics applied to data interfaces, but you will see it applied to functions and classes possibly. Where generics appears quite a lot actually is in the area of promises. So there's a second file here called promises. Now, just for illustration purposes, you might remember in the Web App Dev module last year, we were using this random user web API. And what it allowed us to do is send HTTP GET requests to the random user web API, and it randomly generated user profiles and then sent back an array of those user profiles to us. You might remember that from last year. So I'm just leveraging that to illustrate the use of generics in relation to promises. Now, what I'm showing you here is this is just the structure. Let me just collapse that there. This is the structure of a user profile. So I just went ahead and typed it all up for myself. Nothing terribly interesting. This is the structure of the response that comes back from the random user web API. The body of the response that comes back is an object. The object only has one key called results, and that key is assigned an array of random user profiles. And I've already defined an interface for a random user just above. So it's an array of these things. That's fine. Nothing terribly new there. Here then I've got what else have I got? Oh, let's skip over that. We don't need to worry about that. So I've got a function, an asynchronous function. And the idea is you pass it a URL. In our case, well, you pass it a string, but the string will be the URL of a web API. And in our case, it's going to be the random user web API. And when I make a fetch call to that API, and of course that's an asynchronous invocation, so that's why I'm sticking my await in front of it. The response that comes back is really going to be a promise of some sort. Now you might remember from last year, what I have to do is I have to invoke JSON on that response. Because the response that's coming back from my web API is a stream, which could be fragmented and it needs to be reassembled. And really that's what JSON does. It reassembles the fragmented stream response that comes back from any web API. It reassembles it. Now, my piece of code here doesn't know anything about the response read that comes back from the fetch, because it's data that's essentially coming from the outside of my application. So what I need to do is I need to cast it. And this piece of code here, that's what's going on. I'm casting the data that comes back, the body that comes back from the web API. I'm casting it into a structure that I have defined for myself. And what I've highlighted here, this guy, that is, this structure here. If I don't do that, so this keyword here, as, is important, okay? That's what we call the as operator, and it's used for casting. I'm sure casting is something that you would have done in other languages. But if I don't do the casting, or just before I take that out, clearly now, if I do Command K, Command I, that's its type. But if I don't do the casting, I wonder what its type is. See here, the type is unknown. Unknown is a type defined by the language. It's very like the any type. And the name is kind of meaningful. It's essentially telling us that it doesn't know what type this variable is, because the data that's assigned to it is data that came from across the web. So the difference between unknown and any is, if you've got a variable of type unknown, then you're telling the compiler, I will at some stage cast that variable into a known type. And I'm actually doing it straight away. Like you'll notice here now that there's no error here now, just because this type, the type of body is unknown, There's no error. It's not saying, I don't know how to interpret this body variable. But I would have to cast it at some stage. Anyway, I'm casting it straight away. Casting, the only time you really will need to use casting is for this kind of use case, where you're getting data from external to your application. All I'm doing here is you may not remember, we also used an open API called the JSON placeholder API, and that's what I'm talking about here. Now, what's all this got to do with generics? Well, if I do command, sorry, now if I do, oh yeah, here it is here, right? The return type of this function is a promise, and it's a promise of an object of that structure. And I think if I even took that out, if I didn't explicitly cast it, because promises, we know promises are, to pardon the pun, they're kind of generic, right? They could relate to any data type. So that's why the use of the angle brackets with promise will always be the case. Whenever you're using promises, you have to kind of be specific about what is the structure of the promised data. But I think if I take this out, it'll actually work it out for me. Hopefully. Am I getting an error? No. Command K, Command I. Yeah, it's worked it out for me anyway. So promises are a place where you will definitely come across in the rest of this module, and because they're generic, promises are generics based. So you're now kind of familiar with the syntax. That's the message I'm trying to get across. That's generics. Pretty tricky subject, I have to admit. Okay, there's one or two little exercises in the lab on generics, and they're a bit of a head scratcher really initially. So don't worry about if you're scratching your head a little bit to try and work them out. It's the only time you will have to write your own, or kind of create your own generic types. The last thing I want to talk about is utility types. And as their name suggests, these are types that you can avail of. They kind of come with the language. So I'm saying here that TypeScript provides several utility types, and they're actually published as part of the in the TypeScript documentation. And that's the screenshot at the bottom there. Is just literally taken out of the TypeScript online documentation. There's a section on utility types. And what they are for is they are for transforming, I'm saying here, transforming your types into other types. And the transformations are typical transformations that we find ourselves needing to do when we're developing TypeScript code. And so if it's something that lots of developers find themselves needing to do, then that's why the TypeScript design people gave us these utility types rather than us having to define them ourselves. They're actually, the open source community have also contributed tons and tons of utility types, which you needn't worry about, but they're out there, so to speak. Just one or two examples of some of the standard utility types, and I'm saying here that they're available globally, so you don't have to go importing anything to use these utility types. They're just available to us, unless it's a utility type defined by the open source community, then you may have to import them. But let's just see one or two examples. So what have we got? We've got a tech user interface. Tech user has a name, an ID, an array of, let's say, an array of programming language names, and an optional email. That's fine. So here's one utility type, the partial utility type, and it is actually, all of these utility types are, if you found the implementation of them, you would find that they use generics, and we can see that here. Now, what the utility type does, though, is, or how you use it is, you pass it one of your types, and what it returns is a new type where all of the properties of the type that you pass it are made optional. So if I do Command K, Command I over this guy, okay, you can see all of the properties are optional, whereas in the original one, only some of them. And so there are use cases where you may need to do that, where you have an existing structure, but you actually want to create a kind of another version of that structure where all of the properties are optional. Here I'm actually using it. Am I using it? Yeah, I've got a merge function. The idea is that I give it a tech user and I give it some essentially updates to that tech user. But the updates could be any part of my tech user's properties. So maybe I want to update their name, or in another case, I want to update their list array of programming strings, whatever. But so now overrides now is my transform type. So this again, Command K, Command I on this guy. All right, Command K, Command I on this guy. Well, okay, it's my new type. It's this one up here, and we know that they're all optional. And so I'm just merging the two structures together. Nothing terribly interesting there. That's partial, converts all properties to being optional. Okay, I'm just invoking it there. You can play with that yourselves. The required, that's another utility type, and it's kind of the opposite of partial. What required does is it takes this type, which is one of your types, and it makes all of the properties mandatory. Now in tech user, I had email as being optional, but if I look at this new transformed type, you can see that email is now mandatory in this one. And there may be a case where you actually need that. I mean, the alternative is just you go away and define this, you kind of copy and paste, you copy and paste the definition of this one, assign it to this one, and just change the optional fields to mandatory. But why bother with all that stuff when you can just use the required utility type to do the same for you? Pick, essentially, you pass it one of your data types, and you're telling it to just pick out these properties within this type and assign that to my new type. So it's unfortunate that they use this operator now. Don't kind of interpret this as or. It's really more an and in this case. I want to take the email property and the name property. I want to pick them out of this one and make that a new type. And so again, Command K, Command I in this one. That's the structure. And it's holding on to the fact that email was optional. That was a characteristic of email in this guy. I could make it mandatory by doing something like required RED. You can actually sort of what's the word I'm looking for? You can kind of nest these within each other. I'm not sure if that's syntactically right now, though. Yeah. Does that work, I wonder? yeah, you can see email now is mandatory there. Again, I don't, why do I keep saying this? I don't see you doing anything as kind of fancy as what I've just done there now. But you may see, you might come across an opportunity to use it, and that would be great. That's pick. And really, you can read up on these things yourselves. Omit is kind of the other side. What omit does is it takes this structure and it omits from it these guys, and then puts what's left into this new type. You can do Command K, Command I, and that yourselves. The last one I look at is record. Do I want to look at that? Yeah, so record has a number of uses, but one use case for it is where you want to create a kind of a lookup map structure within your code for kind of fast lookup. In this case, I want to create a quick access map lookup structure for all of my tech users. Okay. And the keys within this map structure will be user's ID, and the value will be the entire user's set of properties. So with record, you tell it what is the basis of the key. So what I'm saying here is that the key of this map will be based on the ID property of tech user, and the value will be tech user programming, which was one of the transformed types that I had earlier on. Which one was it? Let me just see. Oh, it's just up here, right? Sorry, I just missed it. It was this one here, where I'm omitting the ID and the email. So what's left is, what is left? Their name and their array of programming languages. Back to record. So that's what record is trying to do, is trying to create a what I'm calling a fast lookup map data structure. And in this case, it's related to my tech users. So here I've got, what am I doing here? I've got a function. Okay, I've got a function that takes an array of tech users and it returns my map structure for me. And you can, maybe if I just show you what it outputs, you can look at the code yourselves. But if I show you what it outputs, here's my array of, here's my array of tech users, and I'm console logging what this little function returns, and what it returns is my fast lookup map. I just run it. Where are we? 0, 0, 4. Sorry, 0, 4. Here's my map structure here. The keys are the user's IDs, and the value is these objects here. And is that what I'm doing in that little function? So I'm passing it in an array of tech users, and okay, I'm using the array reduce method. I'm passing it in an empty object as the initial accumulator for my reducer, and in the body here I'm just using JavaScript destructuring. I'm taking a user object and I'm picking out the ID property, and I'm putting all of the other properties into a new local variable called other. So this is using the spread operator. It's a bit maybe too fancy stuff going on there now, but so ID is going to have this user's ID property. Other is going to have all of the other properties of user other than their ID. And what my reducer is returning is the current value of the accumulator plus this additional entry that I'm adding into the accumulator. Yeah, have a look at it maybe in your own time, or if you want to ask me a question about it, maybe not. You need time to study it if you want to. Again, the overarching topic here is utility types, and with the exception of that last one, which is a little bit tricky, the other utility types are almost all kind of one-liners, you know, for example, these guys. And so it's just a case of picking out the appropriate utility type for whatever your use case is, which I don't actually see necessarily needing to use. Why do I keep saying that? Okay, now that's as far as I want to go with TypeScript. There's tons of stuff we haven't covered, but that's fine. We've covered quite a lot actually. And it is, I would argue, it's quite a tricky language to get your head around, but practice makes perfect. So if I go back to the website, and if I go to my slides section, can you just give me 1 minute, because my computer is going low on juice, so I just need to plug it in. Right. The next topic I want to look at is something called the Cloud Development Kit. And this is bang in the center of this infrastructure as code idea. So where are we on time? Okay. So I'm just going to, what I want to do is introduce the concept of infrastructure as code. We'll talk about how we got to where we are today in this idea. And then introduce the CDK itself, which is what we're going to be using right throughout this module. And the next lab, which really there's no point, I haven't actually revealed it, I don't think. I go into the homework, no. So you're still going to be working on the TypeScript lab next week. And then after that, you will have a lab which is introducing you to the CDK, and then we'll kind of take it from there. We'll talk about serverless then after that. So I want to start looking at those slides on the CDK, introducing the CDK. So CDK, or Cloud Development Kit, it's an AWS specific tool or framework, although there is a more general form of it. I don't know how advanced it is. By general form of it, I mean a form of it that you could use with Microsoft Azure or Google's cloud platform. But we're looking at the one that's specific to AWS, and it's the kind of the original, I feel like. It only came out around 2019 though. Now we're looking at version 2. So if you look at, if you're doing Googling around this and you come across any article that's more than, let's say, 2 years old, then you're more than likely looking at version. A context for all of this infrastructure as code stuff. Why do we need it? What is it all about? I know it was mentioned in the DevOps module, so this is probably already familiar to you, but that's okay. What I'm saying here is that the goal here is that we want a reliable and consistent way of provisioning infrastructure, because that reliability and consistency, that's fundamental, not just to DevOps, but also I'm saying it's essential for fast software development. if I'm obviously, the reason we deploy or we provision infrastructure at all in the cloud is so that we can run an application on that infrastructure. And when we're doing any kind of software development, we like to make changes to our software and see the effect of those changes straight away as fast as possible. So we like to redeploy our application as quickly as we can and get some feedback, run through tests, etc., and all that kind of good stuff. Now, often though, it's not a case of where we're just going to be making updates to our application source code. We may actually, as part of our development, be changing some part of the infrastructure, adding to it, taking certain parts out, reconfiguring parts of it. So that really, the line between creating your infrastructure and developing your code, that line is very blurred today. They kind of they overlap with one another, which is why we have this topic called DevOps. Right? In the good old days, devs just talked to devs and didn't talk to ops people, and vice versa. But that's all changed. So we want to be able to provision our infrastructure in a consistent way and in a reliable way. Now, the consistency kind of relates to, you see, I said there we're going to be running an application on top of our infrastructure, and we know that when we're doing software development, we have different environments. We have a dev environment, a test environment, and a prod environment. Well, those three environments apply to our infrastructure as well, because whenever we're making changes to our application source code or into our infrastructure, we're going to be playing with that in our dev environment. And then when we want to do some thorough testing, we probably set up a completely different testing environment, where we run our full suite of tests. But that environment is going to have the same infrastructure as our dev environment, or it must have the same. Otherwise, our test environment is slightly different from our dev environment. And clearly, the production environment has to be a carbon copy of the test environment, which is a carbon copy of the dev environment. So whatever way we provision the infrastructure, the way we do it has to be in a consistent way, so that we can be guaranteed that we have the exact same infrastructure in those three different environments. Equally, many organizations, they actually deploy their applications in multiple AWS regions for performance purposes, to minimize latency. So that means that we need to replicate our infrastructure across a number of AWS regions. And this is another argument why whatever way we do provision the infrastructure, it has to be in a consistent way. So that's the argument that we need to. That's the argument for why whatever approach we use to provision infrastructure has to be consistent and reliable. The problem, though, is that if we take a manual approach towards doing this, then any manual tasks, they lack consistency and they lack reliability by definition. Because if we take a manual approach, maybe what we do is we document the steps that the person who is provisioning the infrastructure, we document the exact set of steps that they need to follow. But like any document, over time, it becomes out of date. Maybe there are changes made to it. There are multiple copies of the document, et cetera, et cetera. So all the problems that you associate with any kind of manual tasks apply here. There is definitely going to be lack of consistency. We often use the term a single source of truth. Okay, initially, the initial document that you have, which documents the manual approach towards provisioning your infrastructure, that initial document is your single source of truth. But as I was saying there, copies of that appear around the place, and there are edits to it, and everybody doesn't have the edited version, et cetera, et cetera. So we no longer have a single source of truth. So a manual approach isn't going to hack it for us. Well, this is where infrastructure as code comes in. Can we actually describe the steps for provisioning our infrastructure? Can we actually describe it in code? Can we encode it in code? And of course, the beauty of code is that every time you run it, it's going to do the same thing. Also, because it's code, we can subject it to source control management, i.e. use Git and GitHub on it. And so if I've got a GitHub account, and that's where I put the code, where the code that it takes care of provisioning all my infrastructure, it's actually written in code. Everybody can clone that repo and use it themselves, and they can push to it and pull from it and all that stuff that we do with Git and GitHub. So we have this single source of truth, that being our GitHub repository. So all of the benefits that we get from source control, which we normally apply to source code, by source code I mean application code, we can apply that now to code that actually takes care of provisioning infrastructure. So infrastructure as code allows organizations to automate and manage their cloud resources in a consistent way. And by resources, I mean, whatever, an S3 bucket, an EC2 instance, an SQSQ, all the other stuff that you know about from DevOps. We can actually provision those in code, which of course you've already done. You've done that in the Python scripting, but there are some deficiencies in that Python scripting approach, which I'll come to. I've kind of already made this point here. Okay, so taking an infrastructure as code approach towards provisioning your infrastructure means we can subject it to version control, source control, whatever you want to call it, and all of the good benefits that provides, including the ability to roll back your code. So if you make changes to your infrastructure as code, if you make changes to it and the changes don't work, they provision the infrastructure incorrectly, or my application no longer runs properly on top of it, then I can roll back my GitHub repository to a previous state when it did work. So I have that. That's not that easy to do if I was taking a manual approach towards provisioning infrastructure. And it also doesn't work when you're using a scripting approach, which I'll explain in a moment. And of course, if we're writing code to provision our infrastructure, then all of the benefits associated with code, like sharing good practices and enforcing good practices, that can apply to our infrastructure code just as we apply to our source code. When I talk about source code, I mean the functionality of your applications. But from GitHub's point of view, code is code, doesn't really distinguish. So IAC, or infrastructure as code, has been around for quite a while. And the first incarnation of it is in the form of scripting, which is what you would have done in DevOps last year. And you know the idea. Okay, let's stick with Python and Boto 3. You write your Python script, and when you run your Python script, what that does is it essentially talks to the AWS's web API, okay, and on the AWS side, on the cloud side, it goes away and creates the various resources as dictated by your script. So it could be an S3 bucket, an EC2 instance, an application load balancer, whatever. And that's great. That was a huge improvement on the manual approach towards provisioning infrastructure. When I talk about the manual approach, as you probably know, what I mean is you use the management console. In other words, you take you take, looks like it's shut down on me now, but you use the AWS Management Console, and you click your way through various pages to construct your to provision your infrastructure, which I'm sure you did in the early part of DevOps, and then you moved into scripting. Here are some of the drawbacks, though, of that scripting approach. Number one, I'm saying what happens if an API call fails. So let's supposing I run my script and the first part of the script creates an S3 bucket. The next part of the script creates an EC2 instance. The next part of the script creates an application load balancer. But for whatever reason, we can get into the detail. Let's supposing the API call to create the application load balancer, let's supposing that fails, crashes, and my script throws an exception and crashes. The problem now is, though, that my S3 bucket and my EC2 instance are up there and running. And all I can do is go back to the management console, take those down, and then modify my script to correct whatever caused the problem and run it all over again. That's okay, but that's pretty, that's not a nice experience really to have to kind of resolve issues that way. It would be nice if once my script failed, somehow all of the infrastructure that has been created so far is destroyed or removed. Now, I don't have to do that in code. It would be nice if it was done some other way. But if I have to code it manually, then this script starts getting very long-winded and unwieldy and unmaintainable. Second problem is, how do I make updates to the infrastructure? So I write my script and I run it, and it all runs perfectly, and it creates all my infrastructure. But further down the line, I want to make changes to my infrastructure. The only way I can do it is to actually use the management console. Okay, I could change my script, but if I change my script, I have to go over to the management console and get rid of all of the infrastructure and run my script all over again with the updates to it. Again, there's this going back into the management console and doing stuff there that's really manual, right? And we just don't like that. Number three, how do I know when a resource is ready? In particular, if you're creating an EC2 instance and maybe that EC2 instance has some user data to do some bootstrapping, how do I know if it all worked properly or not, other than going to the management console and poking around? Number four, how do I roll back? Big problem. Again, you have to resort to going back to the management console to undo things that were done by the script. It's not automatically built into the scripting. So the scripting solution is brilliant to create infrastructure. But if you want to make changes to it, roll it back, or if only part of the infrastructure was created, then you're in trouble. Now, the solution to that problem was recognized very early on, and the AWS people themselves and the other cloud providers, they provided what's referred to as a resource provisioning engine. In the case of AWS, the resource provisioning engine is a service called CloudFormation. Now, I know CloudFormation would certainly have been mentioned in DevOps, but you may not have actually done anything with it. But it's a service like any other service. So if you go over to the management console, it's just one of the services in that list. I can't use it now because this thing crashed on me, but you can actually see I happened to be on it there a while ago. So the CloudFormation service is just another service which you can play with manually. But we don't like that. But in terms of what its role is, what the role of this CloudFormation, or to give it its kind of technical name, this resource provisioning engine, the name kind of is indicative of what it does. It's an engine for provisioning resources, i.e. creating infrastructure resources for you. And in the case of AWS, or in the case of CloudFormation, what you do as a developer is you write what's called a CloudFormation template. That's represented by this here. This is written in either YAML or JSON. So that's our code essentially. Okay. So you describe the infrastructure that you want in this template. You then send that template, pass it up to the CloudFormation service, and it interprets it and goes away and creates all of the resources for you. Now, here's the thing though. If I then go along and make changes to this template, and I send that up to CloudFormation, it will actually compare my new version of the template to the existing state of my resources. It will work out what needs to change, and it will make those changes. So it's taking care of updating my infrastructure for me. All I've got to do as the developer is change my template, make the modifications to my template. I don't have to go through tearing down all the resources and just start all over again. CloudFormation. In addition, what's nice about this is supposing the template, the initial template, or even an updated template, supposing I make an error in it. Well, let's take the first case. So I write my template for the first time, and there's an error in it. Pass it up to CloudFormation. It's actually going to spot it straight away. It's not going to go creating resources and roll it back. And even in some cases where you pass it up the template, it starts creating resources, and for whatever reason, the creation of one of the resources throws an exception, then automatically CloudFormation will take care of either getting rid of all of the resources it has created so far, or in the case where I've updated my template, I've given the updated template to CloudFormation, and it makes changes to the state of my resources. If one of those state changes causes a problem, then it will automatically roll back that resource and all of the other resources that it may have changed. It will roll them back to their previous state. So it takes care of all of those problems that we associated with the scripting approach. And I keep using that word state there. CloudFormation talks about the current configuration of all of the resources. We refer to that as the state of your set of resources, state of your infrastructure, in other words. So from your point of view, it all hinges around this template that you are writing and updating. The problem, though, is the template is a JSON document, or you could use YAML as well, which is slightly better than JSON, but it's not very nice, really, writing that kind of code. So the advantages are it's easy to update, which I've tried to explain there. Just make changes to your template, and then CloudFormation takes care of all the rest. It's reproducible. In other words, this template that I've written, I can use that to create my infrastructure for my dev environment, my test environment, and my prod environment. I can use it to create the infrastructure across different AWS regions, all that stuff, because it's completely automated. It's CloudFormation is doing all of the provisioning for me. The downside is the syntax is not nice. It's essentially, we know, or we refer to JSON or YAML as declarative syntax. But either way, it's just not a nice syntax. And also, I'm saying there are no abstractions available to you. So what happens is that these template documents tend to be very long. You've got to, like, if I wanted to create an EC2 instance, I've got to tell it everything about the configuration of that EC2 instance. CloudFormation won't assume default values for certain characteristics of the configuration. You've got to tell it everything. Hence the document tends to be quite long. So no abstractions is a real downside, as well as the syntax. But still, it solved the problems associated with the scripting approach. Now, just taking a step back now, kind of, and re-looking at this in kind of the same way, but this kind of diagram on the right here. So, first of all, what AWS gave us is it gave us a web API interface to allow us to create infrastructure. And that's what, when we're using the management console, we're using that web API. And when you're using scripting, when you're using scripting, you're using the SDK, if you remember, which was Boto3. Boto3 was the SDK for Python. And that SDK was essentially sending HTTP requests to the web API provided by AWS for the purpose of provisioning infrastructure. That's what was happening behind the scenes, as you know. And that SDK, used Boto3, which is the Python one, but the SDKs were made available in various programming languages by AWS. So you didn't have to use Python last year, but it certainly would be very popular in the community. So that was fine. Then CloudFormation came on the scene. So I'm saying around 2011, CloudFormation came on the scene, and I've talked about that. Okay. Now, this HCL there, if I go back to the previous slide, so you write these templates using in JSON or YAML, which is a very long-winded syntax. Now, an organization or a company called HashiCorp, which I'm sure you've heard of, they designed a language called HashiCorp Configuration Language, or HCI. And it's a much cleaner syntax than JSON or YAML. And what happens, the way it works is you write your HCL code. That code is used by a framework called Terraform, which is also provided by the same organization. And what Terraform does is it's a kind of a framework. What Terraform does is it converts this syntax into JSON or YAML, and then we're back to here again. So rather than writing JSON YAML templates, you essentially write your templates using this HCL syntax, which was an improvement on JSON or YAML. So that's what I'm talking about here. That came around 2014. So we're at 2014. The next improvement on this infrastructure as code is the CDK. And the CDK allows us to do everything that HCL does and the JSON YAML documents do, but we write our infrastructure as code using imperative programming languages, which we would be familiar with from application development, whether that be TypeScript, JavaScript, C#, Python, blah, blah. There's loads of languages, Go, and lots of other languages. So I'm saying we're talking about late 2019 was when the kind of proof of concept of the CDK, that's when it came on stream. So it's a framework, and it has a tool, a CLI tool accompanying it as well. Now, in my diagram here on the left, so we have our web API, which was first provided by AWS. Then they provided us, the community, with the SDKs. Then they came along with CloudFormation, that resource provisioning engine. The the nice aspect of CloudFormation is that it managed the state of your infrastructure. This is a really important term, like in the ICE infrastructure as code lingo. CloudFormation managed the state of your infrastructure, which means if you want to make changes to your infrastructure, what you are changing is the state of the infrastructure, and you need to describe to CloudFormation what is the new state you want the infrastructure to move to. And CloudFormation will work out what changes need to happen to the current state of the infrastructure in order to get it into the new state that you want it to be in. By new state, we simply mean I want to change some configuration of some resources. I want to add some resources. I want to remove some resources. Okay, they all relate to this notion of state. So CloudFormation managed the state transitioning of your infrastructure. The way you communicated with CloudFormation was using a declarative coding syntax, i.e. JSON, YAML, or HCL. HCL was also declarative. In comes the CDK. The CDK is also interested in managing state, but the CDK allows us to describe the state of our infrastructure using an imperative programming language, which programmers prefer. All programmers prefer, well, most programmers prefer working with imperative programming languages rather than declarative programming languages. What the CDK also provides is loads of class libraries, and these class libraries, they take care of, if I just go back, I was complaining here about the fact that one of the disadvantages of these CloudFormation templates is that there were no abstractions available to you. You had to be specific about every detail about the configuration of a particular resource, whereas the class libraries provided by the CDK, they actually allow you to assume default values for certain configuration settings for a particular resource, which means often you have to write very little code in order to get a reasonably sophisticated resource configuration. Just bear with me again for a second. All talk so far I appreciate now, but that'll change fairly soon, and it'll be hard code. What else are we seeing here? So we're now describing our infrastructure state using an imperative programming language as opposed to a declarative programming language, and we can pick any one of the languages we want to. That's the volume of code that we write using whichever language we choose. The volume of code is much less than the volume of code that you would write if you were using CloudFormation's own templating syntax or the HCL templating syntax. That's the point I'm making here, that the line of code count, CF there stands for CloudFormation. The CloudFormation templates line of code count is much greater than the CDK line of code count, as we'll see. And because we're using imperative programming languages, we get all the benefits associated with IDEs, like hinting, IntelliSense, all that good stuff. And we can do something called unit testing. We won't be looking at unit testing, but the notion of unit testing and integration testing, or any type of testing at all, automated testing now, that really didn't exist with CloudFormation templates or indeed the scripting approach, whereas it is possible with the CDK. And there are alternatives to the CDK out there now, but we're just going to look at CDK itself anyway. So we're going to use this CDK framework to code up our infrastructure. And so with any framework, there are certain concepts or constructs that you work with. Now, whenever we talk about code, we talk about applications. So CDK talks about an application as well, even though we tend to associate applications with functionality. But in this case, our application is concerned with infrastructure. But anyway, we talk about the notion of a CDK app or application. And a CDK app is comprised of what are called stacks. A stack is comprised of what are called constructs, and a construct is comprised of resources. So resources is down at the AWS level, like a particular S3 bucket, a particular SQSQ, a particular Lambda function, a particular EC2 instance. A construct is a combination of resources that logically go together. A stack is a collection of constructs that logically go together, and a collection of stacks makes up your entire infrastructure. Okay, a collection of stacks make up your entire infrastructure. Now, in our case, our applications, our CDK apps will really only have one stack. The stack will have multiple constructs, and its effect will be to create a number of resources down or up in the cloud. And this is kind of a visualization of it. So I've got my CDK app. It's made up of stacks. Each stack can have multiple resources, and eventually then each stack has multiple constructs, and then each construct is concerned with provisioning a particular resource. So it looks like this one provisions an S3 bucket, and this is actually the DynamoDB database, which is one of AWS's database resources. This one here provisions a Lambda function, which we'll talk about later on, and an SQSQ. So you write the code for this, right? Which we'll see a little bit later on. The way it works then is, so you write your CDK application code. When you run that code, what happens is the CDK framework itself takes it and creates the CloudFormation template corresponding to that. We always have to come back to that. The CloudFormation template is given to the CloudFormation service, and it goes away and provisions the various resources based on that template. Okay, so that's the way it works at runtime. Sorry, that's the way it works when you kind of run your CDK app, because running the app really means you want to provision your resources or update your resources or your infrastructure. I'm saying a stack is the unit of deployment. So technically, if you had an application that had multiple stacks, maybe when you make changes, you're only making changes to one stack. So you only need to redeploy that stack. In other words, go through the create template, give template to CloudFormation. So you can say, I just want to redeploy one particular stack within my application, as opposed to deploying all of the stacks, because presumably redeploying all of the stacks just takes the CDK longer to work out, creating all these templates, et cetera, et cetera. Eventually we see a bit of code, even though I've minimized it because we don't need to get into detail yet. But here's when I talked about the line of code difference between CloudFormation and the CDK on the left. Sorry, no, I'll leave it at this now, and when I'm finished. On the left, I have some CDK code written in TypeScript, coincidentally, and you could kind of work out what it's trying to do. This looks like, maybe this isn't as obvious, but all this line is doing is saying get a reference to the default VPC associated with your AWS account. This one here, we could maybe have a guess at what it's doing. It's provisioning an EC2 instance, and I'm associating the EC2 instance with the default VPC instance. I'm here saying that I want the type of EC2 instance to be a burstable type. It's a T2 micro. What else? This is the particular AMI Amazon machine image that I want to have running on my EC2 instance. And what's this all about? It's going to be running the Linux 2 OS on top of that image. Okay, sometimes I'm using a key pair here. You actually don't have to sometimes, but so that's going to provision an EC2 instance. The CloudFormation template corresponding to that line of code, to that piece of CDK code, and there's 12 lines of code there. The CloudFormation template generated from it comes to 150 lines of code. So if we didn't have the CDK and we only had these JSON stroke YAML might be slightly shorter, but this is JSON. If we didn't have the CDK, we'd have to write 150 lines of JSON code instead of 12 lines of CDK code. Okay, that's the win. But not just that, the CDK also takes care of, so if I want to make a change to some part of my configuration, just change the code here and rerun it, and it regenerates the new CloudFormation template for me. It gives that to CloudFormation, and it takes care of carrying out the necessary infrastructure state change. Right. That's it. I'll leave it at that for now, and we'll pick up the story the next day. Apologies for the various interruptions, but there you go. That's live transmissions for you. Okay, thanks for tuning in. I'll meet you next week.